Example 11 says solve the inequality A. We have x x cubed minus x squared minus 2x is greater than 0. Let's solve this inequality. X is common, so factor out m. X, we have x squared minus x minus 2 is greater than 0. X, let's factorize this. The inside by trial and error. Alright, so this is x here, x here. I have 2 and 1. One of them must be negative, so this is negative and this is positive. Alright, let's get my critical values. X into x plus 1, x minus 2 is equal to 0. Now I have what? Therefore, x is equal to 0, or x plus 1 is equal to 0, or x minus 2 is equal to 0. So, therefore, x is equal to 0, or x is equal to minus 1, or x is equal to 2 are my critical values. So, let's see if we can put these on a table of values. I have what? X is less than minus 1. X is less than 0 but greater than minus 1. X is less than 2 but greater than 0, and x is greater than 2. Alright, those are my range of values of x. This is x, x plus 1, x minus 2, and we have x into x plus 1, x minus 2. If x is less than minus 1, for example, minus 2, x would be negative. Minus 2 plus 1 is still negative. Minus 2 is still negative. If you multiply 3 negatives, you're going to get a negative. Alright. If x is less than 0 but greater than minus 1, for example, if x is minus a half, this would be negative. Minus a half plus 1 would be positive. Minus a half minus a half minus 2 would be negative. And if you're multiplying two negatives, the answer must come out positive. Here we have what? If x is between 2 and 1, for example, if x is 1, this would be positive, this would be positive, and this would be negative. So the answer here is negative. Alright, a positive times a positive is a positive. Multiply that positive by a negative, and you're going to get a negative. If x is greater than 2, for example, if x is 3, this would be positive, this would be positive, this would be positive. The answer would come out positive. Alright, so we're asked to solve the inequality. The solution for the inequality is x cubed minus x squared minus 2x is greater than 0. Greater than 0 means that it's positive. the solution is here and here. So my solution is x is less than 0 but greater than -1, and x is greater than 2. That's my solution for the inequality. The second part of the question, the B part of the question, BI says, hence find the interval for which f of x, f of x, for which f of x is equal to 3x to the fourth minus 4x to the third minus 12x plus 5 is increasing. So this is f of x is equal to 3x to the 4 minus 4x to the third minus 12x plus 5. All right, let's see if that was what I saw. All right, 3x to the 4 minus 4x to the third minus 12x plus 5. Yep, that's exactly what I saw. So let's go back and solve this. All right, first of all, a function is increasing if the first derivative is greater than 0. So um, let's find the first derivative, f prime of x, which is equal to 12x to the third minus 12x squared minus 12. Alright, this is the first derivative, and this must be greater than 0 for the function to be increasing. Alright. I'm sort of wondering if there's a little error with this, because it's not matching up. If I were to divide this, by 12, it wouldn't match up, so the ends part of it would not be so easy. So I'm wondering if that should have been minus 12x squared. Let's put it in place for the time being. If anything, we can go back and check it. If there was a square here, all right, and if there was a square there, there would be a square here, and if there's a square there, this would have been 24x, and this would be greater than 0. If I divide the entire equation by 12, I'm going to get x cubed minus x minus x squared minus 2x is greater than 0. Alright, so let us see if that fits. So that fits A. Yeah, it fits A, and we already have the solution for this. The solution for this is minus 1 is less than x but greater than 0, and x is greater than 2. Alright, so that would be the values of x for which f of x is increasing. And II is asking for the what? II is the region for which f of x is decreasing. So f of x will be decreasing when the first derivative is negative, and that would be here and here, here and here. So I could then say that f of x is decreasing where x is less than minus 1 and x is less than 2 but greater than zeros. Alright, so those are the values for which x squared, x cubed minus 2 minus x cubed minus x squared minus 2x is greater than 0. Those are the values for which it is greater than 0, and those are the values those are the values these are the values here for which x cubed minus x squared minus 2x is less than 0. And the values for which that is less than 0, that's the first derivative. The values for which the first derivative less than 0 are the values of x for which the function is decreasing.